Alright, welcome to this week's Physics Solutions by me. Okay. Hello, I'm going to be solving questions today from the physics homework and hopefully uploading it to YouTube in due time. Right now, I'm going to start off with question 4. Right, we've got sinker times. So, a density of a piece of balsa wood is 0.792 grams per centimeter cubed. What is the initial acceleration when you release this piece of wood underwater? So, this question pertains to buoyancy and this such. So, first of all, we're going to start by, before we even start the questions, there's units that are not in SI units, which will be an issue for us. So we got 0.792 grams per centimeter cubed for the first part. That's 0. Now this is an issue because these aren't SI units, and generally when you're computing issues, you want to use SI units. Sometimes you'll be fine, but other times you may run into issues when doing questions. So converting this to SI units, it's pretty simple. So we can convert to centimeters first. So how many centimeters cubed are in a meter? Well, there's 100 this way, there's 100 that way, and there's 100 up. So it's 100 by 100 by 100. And this, of course, is a square. So that's how we convert that. So we need to multiply these centimeters to convert to meters by 100 cubed. So this is a fraction, so what we do to the bottom, we must do to the top if we want to maintain our ratio. So we multiply this by 100 cubed, which actually simply just gives us 792 kilograms. And of course we change that to meters cubed. So we have 792 kilograms per meter cubed. The density of water for this question is not stated anywhere in the homework. So what you have to do is actually read the book, which I didn't do, and I was using the wrong weight for water, and this really sapped a lot of time because I just couldn't get the question right. But then I got the right answer. I got the right information needed to solve the answer, which is 1,000 kilograms per meter cubed for water. So these are our simple weights which we're going to need to solve this buoyancy question. So you need the liquid and you need the mass of the object in the liquid. So just drawing a simple force body diagram, I think that's what it's called, you can just draw the forces out. So this thing is submerged, and let's find the acceleration. To find the acceleration, we need the mass, we need to know the mass of the object, and we need to know the forces, because F equals ma, mass and forces. So let's do the mass first. So how we do the mass in this question is we just have to make it up, because there is no mass. This sounds dumb, and well, I don't think it actually is. Once you understand why this happens, I think it makes a lot of sense. So what we're going to use for mass is we're just simply going to use like 1 meter by 1 meter by 1 meter cube. Why this? Because we already have our kilograms per meter cubed. So if we just use this, we're going to have all our masses perfectly fine. And now we just now we need to work out the forces. So downwards is just gravity. So it's just 792 multiplied by 9.8. And throw that in the calculator. 792 times 9.8. which just gives us 7761.6 newtons downwards. Now upwards is a bit more tricky. We're just going to have to use the buoyancy formula, which is something you just have to learn, unfortunately, I think, because I couldn't find it in the log tables. So we simply know the buoyancy formula, which because you're supposed to learn it or something. So we know that it is rho, which is the density, by the gravity, by the volume displaced. and that's it. So now we just fill our formula in. Rho is the sort of density per volume, which for water, which is the liquid being displaced, is simply 1,000 multiplied by gravity, which is just 9.8. And our volume, we chose a 1 meter by 1 meter by 1 meter cube. So our volume is simply just 1. You could choose any volume or mass or whatever. You could choose, I don't know, half a meter cubed. But that would just make things more complicated, so it's completely not worth it. So we got our upwards force and a downwards force. So now we can take them away to find the net force, which is 9,800. Take away 7761.6, or just we can drop it at 6 because it's just a tutorial video. The exact answer does not matter here. And subtracting our upwards force from our downwards force gives us 2039, which is the upwards force. So once you've got a force and once you've got the mass, which we, once again, by setting it to a meter cubed, we've made that much easier because we know the mass, because it's given in the question and we converted it already. So 792 kilograms is our mass and our force is 2039. So now we can just simply use F equals ma to find this. So our force is 2039 equals our mass, which is 792, and a is unknown. So now we can just divide this number by this one, and that gives an acceleration of 2.573. I've already done this question before, so I know the answer, and that is it for me. I'll do question 5 now.